parking lot that vehicles do not slow down when approaching it. The second type is called abstract parking lot. For the abstract parking lots, vehicles, when approaching them, will slow down, and they will enter one by one. So the capacity of these abstract parking lot is limited. It's almost 700 vehicles per lane. So the vehicles will slow down, enter one by one. And these are the two types of parking lot you want to use in DTA today. The third one is called the real parking spaces. So real parking spaces is like roadside parking spaces, and the capacity of them is not defined by you, but it's limited by the length. So you will see it on the network, and you can calculate the length, and the length divided by the length of vehicle can be roughly used as the estimation of the capacity. And for real parking spaces, they can be grouped. So you can have one here, one there, but you can group them as one parking lot group. So the vehicles will automatically choose the one that still has some capacity, some availability. So let me show you how to do it. In vSim, and in today's network, today's example, I'm using a network that I created to show you how to do one step by step. But you can also find a similar one in the program data folder of vSim. So this is a very simple network. So I have the first link, the second link, third link, and the fourth link. So 4 links and several connectors. Connectors, right? So just connectors as you created. So it's very simple. And this is the start point, this is end point. To create a parking lot, we select this tool. Let me hide it. We select this, select this tool, P, and we can then create parking lots. In this case, I created 2 parking lots. One at the beginning link here, the other one at the end of the link here. Okay, so to create parking lot, you click the parking lot button and you select the link, and then you use your right button to drag a line, and this will become a parking lot. In the parking lot, you can choose the type, and by default it's real parking spaces, and you can, in this dynamic assignment tab, you can specify the zone ID. It's very easy. Okay, that's very easy. It's very easy to create a parking lot. And there are some restrictions. A parking lot must be on a link and it must be between 2 nodes. Do you remember the nodes you created? So the parking lot cannot be intersecting with any node. And it can either be on a link between 2 nodes or fully inside an internal node. An internal node is a node that is not at the border of the network. And there can be only one at most between a link. And there can be only more than one. There can be no more than one parking lot inside the internal node. So these are the restrictions. Now, as I already mentioned in the beginning of the lecture, to do dynamic traffic assignment, we need nodes. We need an abstract links or abstract network. The 2 elements of the abstract network are nodes and edges. We already know what nodes are, but this time I want to emphasize these edges. In vSim, edges are different from links. Edges are the virtual links that are automatically created by vSim. As long as you created the nodes, vSim will automatically create the edges. And the edges do not consider any traffic, node impedance like turning or any traffic signals. So the abstract network is created by vSim. Let me show you more about nodes. Within this within this network, I created 4 nodes. See, 1, 2, 3, 4, 4 nodes. For each node, if you double click it, you select it, you are going to see its property. And in this property, you will see if it's included in the dynamic assignment. And here you will see orientations. For example, this is node 2. And we see it has a neighbor, node 1, to its west. It has another node to its east. So these are automatically created. But in some complex situations, you may want to change that by clicking this user-defined orientations. In this case, we don't need it. The nodes should not overlap. Okay. Another thing you want to check is this edge. So you go to Edit menu and you will find this edge selection. Be sure you select this thing first. If you don't select the node mode, you won't be able to use this menu. So use edge selection. You will be able to see from node, for example, from node 2, from node 3 to node 3 or node 4. So you will be able to view the edges that are automatically created, and this dialog allows you to temporarily or permanently close some edges. So if you don't want them to be used in simulation, in an assignment, you can close them. The next important thing is the input of trips. So it's called OD matrix, as I mentioned several times. In vSim, the OD matrices are stored in text files, ASCII text files, and they have an extension FMA. But in vSim, you are not allowed to create them using any tool. You have to use external tools like the text editor to create your own OD matrix. The format is actually very, very simple. So the star means commenting. Okay, so the second line means the time interval, 0.00 to 1.30. That means this OD matrix is for a certain time period, a certain time interval between 0 o'clock and 1.30 o'clock, which means 90 minutes. No, not 90 minutes. 1.3 hours after the starting. So this is the time interval. And it has a scaling factor. By providing this scaling factor, you can apply a multiplicator to this OD matrix. And you have to specify the number of zones and the zone IDs. These zone IDs are the same as which you define in the parking lot. And this is the OD matrix. And for example, this one means from zone 2 to zone 3, within this interval, there are 190 zones. Trips, 190 trips. So you have to provide this, and I'm going to upload a simple example so you can follow. Okay, so almost all the functions of dynamic traffic assignment in vSim can be accessed through traffic dynamic assignment. You are going to see a very long dialog from the top to the bottom. The first thing I want to talk about is called trip chain table. In vSim, you are allowed to model the trip chain, which means a user can go to several different places one by one. But this is very difficult to model. So if you're interested in this, you can try to use it. The second thing is called, there's a tragedy, I couldn't. It's really bad that I'm using a bigger font, so something disappeared between them. So embarrassing. So here, actually, there should be a tape. There should be limited by the resolution. I couldn't see it. So probably I have to take some time to do it. there is a button between the first two buttons talking about the OD matrix, the most important thing. So can I could you allow me to restart my computer? Sorry, this is so critical, so could you just pause? Sorry, when I use smaller phones, I was able to see these options, matrices. And here you can click edit to specify your matrix file. So let's browse. Let me just browse for my demand.fma that I already introduced. So by doing this, you are adding the OD matrices to the dynamic assignment procedure. I want to explain this DTA dialog. So there are several things to talk about. The first thing is called the evaluation interval. In vSim, for example, your simulation time is 1 hour, but you can cut this 1 hour into several intervals, and each interval is called an evaluation interval. In vSim, those intervals are not assigned together at the same time. So in vSim, we will first do the traffic assignment to the first interval. Then after it's running for that interval long, it will start another dynamic assignment. So the intervals are meaning the different intervals for assignment. And as I already talked about, in order to calculate the generalized cost, we need to estimate the travel time of each link first. And in vSim, you can select two methods. The first one is called exponential smoothing. The second one is called MSA. Okay, and these are equations. I just want to emphasize that they are of almost the same format. So this thing, this T, is the expected travel time of an interval of an edge. This is the travel time we need. And this is the travel time in the last iteration. Iteration means you run the model several times. One time will be called an iteration. So the travel time, or expected travel time that is going to be used in this iteration will be a function of the last travel time, the last iteration, and the observed travel time in the last iteration. Right? Okay. Or this one. So, and this, I think this is going to be used in the next time. So, it's a function of the observed and the function of expected. And here are two weights, 1 minus alpha and alpha. This is another function of 1 minus something and something. So it's a weighted result.
So observed is the current, time interval.
Yes.
And expected is the